In the Name of God. Sophia's Programming Journey. Highlighting faces in images using OpenCV and deep learning. Introduction. What is facial detection? Applications of facial detection. The importance of accuracy. Challenges in facial detection. The role of deep learning. The OpenCV library. The face detection algorithm. Code implementation. Importing libraries. Loading the face detection model. Defining the highlight face function. Setting the confidence threshold. Creating a copy of the frame. Getting the frame dimensions. Creating a blob. Setting the input for the model. Getting the detections. Creating the face boxes. Drawing the face boxes. Returning the frame and face boxes. Running the code. Conclusion. References. Questions. Welcome to the world of face detection. In this presentation, we will explore how OpenCV and deep neural networks can be used to highlight faces in images. We will delve into the technical details of these powerful tools while keeping the tone informative and engaging. Face detection is a crucial technology with applications ranging from security and surveillance to entertainment. By accurately identifying faces in images, we can improve our ability to monitor and protect public spaces, enhance user experiences in virtual reality and gaming, and much more. Join us as we explore the fascinating world of face detection. Face detection has become increasingly important in today's world, especially in applications such as security, surveillance, and entertainment. In security and surveillance, face detection can be used to identify potential threats or suspects. For example, facial recognition technology is used by law enforcement agencies to track down criminals and terrorists. In entertainment, face detection can be used to enhance user experience. For instance, Snapchat uses face detection to add filters and effects to selfies. OpenCV is a powerful tool for image processing and analysis. It provides a wide range of functions that can be used to detect faces in images. One of the key features of OpenCV is its ability to perform feature detection, which allows it to identify specific patterns in an image, such as edges or corners. This is essential for detecting faces, as they have distinct features that can be identified using these techniques. In addition to feature detection, OpenCV also uses object recognition to identify faces in images. This involves training a model on a large dataset of images that contain faces, so that it can learn to recognize them based on their unique features. Once the model has been trained, it can be used to detect faces in new images with a high degree of accuracy. Deep neural networks are a type of machine learning algorithm that are modeled after the structure and function of the human brain. These networks consist of multiple layers of interconnected nodes that process information in a hierarchical manner. Convolutional neural networks (CNNs) are a specific type of deep neural network that are particularly well suited for image recognition tasks such as face detection. These networks use a series of convolutional layers to extract features from an input image, which are then passed through fully connected layers to produce a final output. Training data is a crucial component of deep neural networks. In order to train a CNN for face detection, a large dataset of labeled images must be collected and used to teach the network how to recognize faces. The architecture of a deep neural network refers to the specific arrangement of its layers and nodes. There are many different architectures that can be used for face detection, each with their own strengths and weaknesses. Setting up the environment. Before we can start highlighting faces in images, we need to set up our environment. This involves installing OpenCV and the necessary libraries for deep neural networks. Loading the model and processing the image. Once the environment is set up, we can load the pre-trained deep neural network model and process the image using OpenCV. This involves detecting faces in the image and highlighting them using bounding boxes. In conclusion, we have learned about the importance of face detection in various applications, such as security, surveillance, and entertainment. We have explored how OpenCV and deep neural networks can be used to highlight faces in images, with a step-by-step guide on how to implement it. By using these technologies, we can improve the accuracy and efficiency of face detection, leading to better outcomes in different fields. As technology advances, the potential for face detection continues to grow. It is up to us to use it responsibly and ethically, ensuring that privacy concerns are addressed. Let us continue to explore the possibilities of this exciting field and make a positive impact on society. Facial detection is a rapidly advancing technology that has significant implications in various fields such as security, marketing, and healthcare. It involves the use of algorithms and machine learning to identify and track human faces in images or videos. The importance of facial detection lies in its ability to accurately and efficiently recognize individuals, which can aid in identifying criminals, personalizing marketing campaigns, and diagnosing medical conditions. However, there are also concerns surrounding privacy and potential misuse of this technology. Facial detection, also known as face detection, is a technology that uses algorithms to identify and locate human faces in digital images or videos. It works by analyzing the patterns of light and dark pixels in an image to determine the presence of facial features such as eyes, nose, and mouth. The process of facial detection involves several steps, including image acquisition, pre-processing, feature extraction, and classification. The algorithm first analyzes the image to detect areas that are likely to contain faces, based on features such as color, texture, and shape. It then extracts the facial features from these regions and compares them to a database of known faces to determine the identity of the person. Facial detection has a wide range of applications in various fields, including security, marketing, and healthcare. In the field of security, facial detection is used to identify potential threats and prevent crime. For example, it can be used to detect individuals on a watchlist or to monitor crowds for suspicious behavior. In the marketing industry, facial detection is used to analyze consumer behavior and preferences. By analyzing facial expressions and emotions, marketers can determine which products are most appealing to consumers and tailor their advertising campaigns accordingly. In healthcare, facial detection is used to diagnose and monitor medical conditions. For example, it can be used to detect early signs of Parkinson's disease by analyzing facial movements. It can also be used to monitor patients with mental health conditions, such as depression, by analyzing changes in facial expressions and emotions. Overall, facial detection has the potential to revolutionize many industries and improve our lives in numerous ways. Accuracy is a crucial aspect of facial detection as it determines the reliability and effectiveness of the technology. Inaccurate results can have serious consequences, particularly in applications such as security and law enforcement. False positives, where the system incorrectly identifies a person as a match, can result in wrongful arrest or detainment. On the other hand, false negatives, where the system fails to identify a person who is a match, can lead to security breaches and potential danger. To ensure accuracy, facial detection systems must be trained on large and diverse datasets that represent different demographics, ages, and skin tones. Additionally, algorithms must be regularly updated and tested to account for changes in lighting conditions, facial expressions, and occlusions. By prioritizing accuracy, facial detection can be a powerful tool for enhancing security, improving healthcare, and advancing marketing research. Facial detection technology has come a long way, but it still faces some challenges. One of the biggest challenges is variations in lighting. Different lighting conditions can make it difficult for facial detection algorithms to accurately identify faces. For example, shadows can obscure parts of the face, making it harder for the algorithm to recognize it. Another challenge is facial expressions. Faces are constantly changing, and an expression can completely alter the appearance of a face. Facial detection algorithms need to be able to recognize faces regardless of the expression they are making. This requires advanced algorithms that can detect subtle changes in the face. Deep learning has revolutionized facial detection in recent years, providing significant improvements in accuracy and reliability. By using complex neural networks to analyze vast amounts of data, deep learning algorithms can identify patterns and features in facial images that were previously impossible to detect. One of the key advantages of deep learning in facial detection is its ability to adapt and learn over time. As more data is fed into the system, the algorithm becomes more accurate and better able to recognize a wider range of facial features, expressions, and poses. This makes it ideal for applications such as security, where high levels of accuracy are essential. OpenCV Open Source Computer Vision Library is an open-source computer vision and machine learning software library used for various applications, including facial detection. It was initially developed by Intel in 1999 and has since been continuously improved and maintained by a community of developers. OpenCV provides a wide range of functions and algorithms that can be used to develop real-time computer vision applications. Its role in facial detection is significant as it provides the necessary tools and functions to detect faces accurately. The face detection algorithm used in OpenCV is based on the Viola-Jones object detection framework. This framework uses HAR cascades, which are classifiers that are trained to detect specific features of an object, such as the edges and corners of a face. The algorithm works by scanning an image for these features at different scales and orientations, and then combining these detections to identify the presence of a face. One of the key advantages of the Viola-Jones algorithm is its speed. It can detect faces in real time, even on low-powered devices. However, it does have some limitations. For example, it may struggle with faces that are partially occluded or not facing directly towards the camera. Additionally, it may produce false positives or false negatives in certain lighting conditions or with certain facial expressions. Implementing facial detection using OpenCV involves several steps. First, you need to import the necessary libraries, including CV2 and NumPy. Then, you need to load the face detection model using the cv2.dnn readNet from Café function. This function reads the prototext file, which contains the architecture of the neural network, and the Café model file, which contains the weights of the network. Next, you define the highlight face function, which takes in the frame as an input and returns the frame with the face boxes drawn on it. The function first creates a copy of the frame and resizes it to a fixed width of 300 pixels. It then creates a blob, which is a pre-processed image that the neural network can process efficiently. The blob is created using the cv2.dnn blob from image function, which scales the pixel values to a range of 0 to 1 and subtracts the mean pixel value from each channel. Finally, the function passes the blob through the face detection model and gets the detections. It then creates the face boxes based on the detections and draws them on the frame. In order to implement facial detection, it is essential to import the necessary libraries. These libraries contain pre-built functions and tools that make it easier to develop and run facial detection algorithms. One such library is OpenCV, which is a popular choice for facial detection due to its ease of use and efficiency. OpenCV provides a number of features that are useful for facial detection, such as image manipulation, feature extraction, and machine learning algorithms. By importing these libraries, developers can save time and effort by using pre-existing code rather than having to write everything from scratch. This not only speeds up the development process but also ensures that the code is more reliable and accurate. Once OpenCV is installed, the face detection model can be loaded using the cv2.dnn readNet from cafe function. This function takes two arguments, the path to the prototext file and the path to the cafe model file. The prototext file contains the network architecture of the model, while the cafe model file contains the weights of the model. It is important to note that the face detection model used in this presentation is pre-trained on a dataset of faces and non-faces. Therefore, it is not necessary to train the model from scratch, which can be time-consuming and computationally expensive. The highlight face function is a crucial component of facial detection using OpenCV. Its main purpose is to identify the location of faces in an image or video frame and draw a bounding box around each face. This function takes the input image or video frame as an argument and returns the same frame with the face boxes drawn on it. To accomplish this, the highlight face function first sets a confidence threshold for face detection. This threshold determines the minimum level of confidence required for the model to detect a face. The function then creates a blob from the input frame, which is essentially a preprocessed version of the image that the model can analyze more efficiently. The function passes this blob to the face detection model and gets back a set of detections, which are essentially the locations of all the faces detected in the image. Finally, the function draws a bounding box around each face using the coordinates of the detections and returns the modified frame. The confidence threshold is a critical parameter in facial detection that determines the level of certainty required for a face to be detected. It represents the minimum confidence level that a face must have to be considered a valid detection. Setting the threshold too low can result in false positives, where non-faces are detected as faces, while setting it too high can result in false negatives, where actual faces are not detected. To determine the optimal threshold, several factors need to be considered, such as the lighting conditions, the quality of the image, and the specific use case. In general, a higher threshold is recommended for applications where accuracy is crucial, such as security and law enforcement, while a lower threshold may be acceptable for applications where speed is more important, such as marketing and entertainment. It is essential to find the right balance between accuracy and speed to ensure optimal performance. When working with facial detection, it is important to create a copy of the frame to avoid altering the original image. This allows for multiple operations to be performed on the same frame without affecting the integrity of the original image. Creating a copy of the frame is also useful for debugging purposes. If an error occurs during the facial detection process, having a copy of the original frame can help identify where the error occurred and make it easier to fix. To get the dimensions of the frame, we need to access the shape attribute of the frame. The shape attribute returns a tuple containing three values: the height, width, and number of channels. The height and width are important for facial detection because they determine the size of the image that the face detection algorithm will process. If the image is too small or too large, it can affect the accuracy of the detections. It's also important to note that the aspect ratio of the frame should be maintained when resizing the image for facial detection. This means that the height and width should be scaled proportionally to avoid distorting the image and potentially causing false detections. By getting the dimensions of the frame and maintaining the aspect ratio, we can ensure that our facial detection algorithm is processing images accurately and effectively. In computer vision, a blob is a group of connected pixels in an image that share a common property, such as color or texture. Blobs are often used in object detection and tracking, including facial detection. To create a blob for facial detection, we first need to convert the input image into a format that the face detection model can process. This involves resizing the image to a fixed size and normalizing the pixel values. We then subtract the mean pixel value from each pixel and divide by the standard deviation to obtain a Zero-centered, normalized image. Finally, we convert the image to a blob by adding an extra dimension to represent the batch size. This blob can then be fed into the face detection model for inference. Once the face detection model is loaded, the next step is to set the input for the model. This is done by creating a blob from the frame and passing it through the model. A blob is a binary, large object that contains the image data in a format that can be used by the deep learning model. To create a blob, we first need to resize the frame to the size expected by the model. This can be done using the CV2 resize function. Next, we subtract the mean values of the RGB channels from the image data. Finally, we scale the pixel values by a factor of 1/255 to bring them into the range of 0 to 1. The resulting blob can then be passed as input to the face detection model. Once the input image has been processed by the face detection model, the next step is to extract the detections. The detections are essentially a list of bounding boxes that represent the location and size of each detected face in the image. To extract the detections from the face detection model, we first need to define a confidence threshold. This threshold determines how confident the model needs to be in order to consider a detection is valid. Detections with a confidence score below this threshold will be discarded. Once we have set the confidence threshold, we can then extract the detections by iterating over the output of the face detection model and selecting only those detections that meet the confidence threshold. Once we have detected the faces in an image using the face detection algorithm, the next step is to create bounding boxes around each face. These bounding boxes, also known as face boxes, help us identify the location of the face in the image. To create the face boxes, we use the coordinates of the detected faces returned by the face detection model. These coordinates represent the top left corner of the face and its width and height. We then draw a rectangle using these coordinates to create the face box. The size of the face box can be adjusted based on the application, but it is important to ensure that the entire face is included within the box. To draw the face boxes on the frame, we first need to define the color and thickness of the box. This can be done using the CV2 rectangle function in OpenCV. We can specify the color using the RGB values and the thickness using an integer value. Once the color and thickness are defined, we can loop through the detections and draw a rectangle around each detected face. It is important to note that the face boxes should not overlap or extend beyond the boundaries of the frame. To ensure this, we can use the CV2 clip function to clip the coordinates of the face boxes to the dimensions of the frame. Finally, we can return the frame with the face boxes drawn on it for further processing or display. Once the face boxes have been created and drawn on the frame, the final step is to return the frame and face boxes from the highlight face function. This is achieved using the return statement in Python. The frame and face boxes can then be used for further processing or display, depending on the specific application. For example, the frame could be saved as an image file or displayed on a screen with the face boxes overlaid on top. The face boxes themselves could be used for additional analysis, such as emotion recognition or age estimation. To run the facial detection code using OpenCV, you must first ensure that you have installed OpenCV on your system. Once installed, you can begin by importing the necessary libraries and loading the face detection model. Next, define the highlight face function and set the confidence threshold. This is crucial for accurate facial detection. Then, create a copy of the frame and get its dimensions. After creating a blob and setting the input for the model, you can get the detections and create the face boxes. Finally, draw the face boxes on the frame and return the frame and face boxes from the highlight face function. In conclusion, facial detection is a powerful technology that has numerous applications in various industries. It works by using algorithms to detect and analyze the unique features of a person's face. Accuracy is crucial in facial detection, as false positives and false negatives can have serious consequences. Despite the challenges, deep learning has greatly improved facial detection, and the OpenCV library provides a user-friendly platform for implementing this technology. Facial detection has the potential to revolutionize security, marketing, healthcare, and many other fields. By accurately identifying individuals, it can help prevent crime, personalize advertising, and even diagnose medical conditions. However, it is important to use this technology responsibly and ethically to protect people's privacy and prevent misuse. As with any technology, facial detection should be used with caution and with consideration of its potential impact. Thank you for taking the time to listen to our presentation on facial detection. We hope that we have provided valuable insights into this important topic. Now, we would like to open the floor for questions and discussions. Please feel free to ask any questions or share your thoughts with us. If you have any further inquiries or would like to learn more about facial detection, please do not hesitate to contact us. Our team is always happy to assist and provide additional information. You can find our contact information on the last slide of this presentation. Thank you again for your attention and participation.